Now let's look at how to graph a log function. To graph a log function, we need a table. We can actually fill these attributes a little later because these table values will help you understand, or a graph will help you understand to complete these things in here. One thing you need to understand, the domain of a function is definitely restricted and range is all real numbers. And depending on case to case, there could be x-intercept or y-intercept, but it is not necessary. And there will be definitely one asymptote, and we can determine whether the function is increasing or decreasing by looking at the graph. So let's before we start the log equation, we just make sure we know what is an exponential equation, and we can just find the inverse by flipping the values, and that is the easiest way you can do to start with. So y is equal to 2 to the power of x is going to be our exponential equation with the base 2, and these are the parent points for those for the exponential function with the base 2 right here, -1, 1/2, 0, 1, and 1, 2. And the corresponding log equation, or you can say the inverse of this exponential equation, is the log equation right here, and which is y is equal to log x to the base of 2. You may notice the base is 2 here and the same base here. So just to flip these values, then you will get a table for the log equation, which is going to be 1/2, -1, 1, 0, 2, 1. Let's plot these points in here. So the first I'm just going to plot the values for the exponential function just for you to understand they are inverse to each other. So -1, 1/2, -1, 1/2 right here, then 0, 1, and 1, 2. Then complete the graph, and the graph looks like this. And definitely the x-axis is going to be the asymptote for the first function, which is our exponential function right here, the one in blue. And this is a linear parent function. And second one, we have the 1/2 -1 right here, 1/2 -1, 1, 0, and 2, 1, and complete the graph. And the vertical asymptote is going to be the y-axis, and you can see that right there. And this red one is the logarithmic function. So definitely these two functions are inverse to each other. Values are applied in here, or this rule is applied in these x and y values to get this. This becomes in 4/3 -7, this becomes 2 -4, and 3, 1 becomes a 4 -1. So these are the parent points and the transport points, and this is the graph right here. Okay, those points are plotted in here, and this is going to be our required function. And you know the vertical asymptote, the asymptote is right here, x is equal to 1. And these are the points plotted, and this is going to be our log function for the given function. And quickly go through the attributes. Domain is going to be 1, infinity, because we know the vertical asymptote right here is that's at 1. So anything to the right of that asymptote is going to be the domain of the function. Range is all real numbers. X-intercept is 1 plus 3, a cube root of 3, 0. You can find the x-intercept by setting y equal to 0 in the original equation. Y-intercept, there is no y-intercept because the function never ever crosses the y-axis, so there is no y-intercept. Asymptote, x is equal to 1, vertical 1, and the function is definitely increasing. Finally, number 7. f of x is equal to, this is a natural logarithm function, f of x is equal to -ln x plus 1 plus 2. Okay, we can apply the same transformation rule here, and based on the values that you may get from here, a, b, c, and d, we may be able to calculate this one. A is going to be -1, b is 1, c is -1, and d is 2. Apply those values in this formula right here, and you get the transformation rule, x minus 1 -y plus 2. Parent points are 1 over e. As we know, the base of the parent function y is equal to ln x. Base is e. So as we did here, both the 3's replaced by e, and it is same thing for everything. So y is equal to ln(x), 1 over e, -1, 1, 0, e1 is going to be the 3 points for the parent function. And just to make the transformations using this transformation rule, and you get 1 over e minus 1, 3, 0, 2, e minus 1, 1 going to be the 3 points to be plotted, and those points plotted here. This is going to be the function. Quickly go over the attributes. Domain is -1 to infinite because the asymptote is at -1. Range is all real numbers. X-intercept by setting y equal to 0, e squared minus 1 comma 0. Y-intercept is 0, 2. Asymptote is x is equal to -1. The function is decreasing.